This is a part 2. If you want to see part 1 for a little bit more context, check out the description. There's a playlist as well as a link to the previous video. So let's go back to the tokenizer and look at the other cases. I'm not gonna lie, there's about 100 reasons why that wouldn't compile. I really just want to take all of that, uncomment it, and compile. And I know that rationally it's not gonna work, but I just want to try it. Okay, it didn't build. Oh, it's because they're not even tabbed the right amount. If I do this, they're not tabbed the right amount here. Let's do this. Oh. So it's a primitive. And it's a member call. What? And I'm doing .at. Yeah. I think it's because I don't need that anymore. Yeah, every bit of code I uncomment, I'm surprised that it's actually working. Produced an error. Cannot compare types for equality expression. So here I need to get a better error message. Right was. Now let's add backticks. This is gonna be something like E. Okay, left was program.at index. Right was. Program.at index is a char, and this is a string, or what? When I have a token string, it returns a standard string, primitive type string. I went ahead and implemented a bit of logic to check if a string literal has a single character, it's going to be a character, and if it has a backslash code, it's going to be a character as well. Looking back at this, I did make a mistake with the value contained by the type. I'm not passing the right character, but I'll go ahead and fix that at some point. But now the single characters will be characters and not strings. Returned expression does not match declared type. Expression was tokens backslash. Type was pair int string u.value._value. Return true. I should really rename these parameter and argument, by the way, instead of E and U. Produced error, undeclared identifier std. Ooh. Yep. I can just add another one like exit 1. And now I need to check the type of that thing. We are just gonna have to throw. Now the result is void, okay. Representation and value. Yeah, okay. Now it produced some code, which I'm assuming is correct. Let's just put it in expected and try to compile expected. What the hell? I don't think that's correct. I don't think that is correct at all. Let's try that. Okay, so basically the problem is that I allow people to write stuff like strings like that, right? ABC. And I also allow them to write ABC. But in C++, you cannot write a string like this. You need to use the double quotes. So what I do, if someone writes ABC, quote ABC, is I transpile that to ABC backslash ABC. So that the string has the same content. We escape the quotes here so that if you were to like print this, it would print this. Now the problem is that if the string only has one, character in it. So if someone writes dot, I transpile it to dot, or rather I transpile it to dot, but if it only has one character, it becomes this because I make it a character. So I need to go to here. I need to check if expr.value.at 2 is equal to dot. This is some of the worst code I've ever written because I'm like handling an edge case and fixing it with another handle later. So now, like, believe it or not, it's fixed. So if I get the produced, I throw that in the expected and I compile. This looks fine, but now there's another error. Let's see. No constructor from char to basic string. Wait, it looks to me like I can. Often I call assignable to, but I really want to know, is it the same? If it's not the same, is it assignable to? But I go straight to, is it assignable to? And I end up creating bugs. Because right now, I check that if like a character is assignable to a string and I say yes, but it's not enough. Damn, okay, let's write the problem I'm trying to solve. I have like something like type A, and I have like string X, int Y. And then someone writes something like that. A U equals 1, 2, 3. Five over 2. And now the question I'm trying to solve is how. The first question I have to solve is this okay for A by itself, or is it okay but do I need to change something, such as A U equals string 1, 2, 3 int 5 over 2. Now the problem is that to do that I need the actual expression here. But all I have is the type of the expression. So here it would be string and here it would be int. But if I have this, it's actually not string, it's a character. And then what happens, it looks like that. At this point, I ended up thinking about the problem and working on it for over 2 hours, and I did not come up with a solution that works, so I'm gonna skip over that and I'll take you back at the point where I realized what I was working on doesn't work and work on the solution that does work. So the optional return type is not enough. So if you can't, returning an empty optional works, but if you can, you need to say, well, is it the right type already or do you need to modify it? And so I need three things, not just two. This thing is going to return a variant, not assignable, directly assignable, or requires conversion. God, I'm gonna need to pass the freaking variables in state if I'm doing it this way. Okay, I've really placed myself in a messy situation, but I think just when I started the recording, I found the solution. So actually the solution is that the callback, well, it's not a callback. So a callback is a function that you pass to another function so it gets called. Here it's a function that I'm returning from a function. So it's not a callback, but I'm gonna keep calling it a callback because every time it's the first word that comes to mind. But essentially, the function doesn't just take an expression, and it's going to take the variables. There we go. And now with that information that I don't have it in this context, but in the context of the function call, I will. So that's the beauty of it. All this time I'm considering that maybe I don't even want to do this, by the way. Maybe it should just be yes or no, it's assignable. No, that's the thing. That's the thing. The requires conversion is not for the user. The requires conversion, it's not to save things from the user. It's to transpile it properly. So maybe the user did write correct code, but I need to apply a conversion because of the way that the thing is transpiled. So this is an example of what I came up with here. Not all the cases are implemented in the assign to, but when I was going through the recording, I don't think that the development process really is interesting. So instead I'll just show the final setup. This is specifically for the case that we were looking at where there's something here that expects right, you have a type that has a string and an int, and you're trying to assign something like a single character literal, which is interpreted as a character. So this would get transpiled to in C++, right? I would transpile that to this, right? Because there's only one character. But now when I try to assign this to the type, I know that a character is assignable to a string, and I'm just trying to put basically something like that. So essentially, right, we're trying to add this conversion in the middle of the type for one of the members of the types needs a conversion. So what ends up happening is that basically we check, right, basically here we're checking is the aggregate assignable to the type. If they don't have the same number of arguments, right, if the number of elements in the aggregate isn't equal to the number of member variables of the type, that doesn't work, just not assignable. Otherwise, we're going to make a list, so make a vector of assigned t's, and then we're going to go for each index, right, for each member variable, we check is it assignable, assigned to. If the assigned t is not assignable, then the whole thing is not assignable. But if it requires conversion, we mark that one of the elements requires conversion, so it's not directly assignable. And whether it requires conversion or directly assignable, we push this information to the assigned t's. Now, if it's directly assignable, so all of the members are directly assignable, we just return directly assignable. Otherwise, it means that at least one of the elements in assigned t's is a requires conversion. So we return a requires conversion. And then whenever the caller attempts to call the callback with a conversion, and they pass the state, variables, expression, and we are to return a transpiled expression, what we do is basically for each member in the assigned t's, right, we check if it's right here, okay. So if it's a requires conversion, we call the converter that it produced. And otherwise, we just transpile that. As you can see, there's some to-do remaining where the converter right now takes an expression, but technically it should call an argument. So there's a little bit more work to be done, but yeah. And so, yeah, with this information, that's either just the expression or the converted expression, we basically just put that into the representation. Let's try to run now. Whew, I cannot believe I just spent I probably spent 6 hours working on this conversion. And it's literally pretty much only for this, for character to string. I created a problem myself and I'm having to solve it. This decision was not the best, but it does make the language a little bit simpler to use? Maybe. I mean, I think it definitely does if the compiler works. You can write characters and strings the same way and it just kind of works. Let's hope that I'm right about that. Now, I guess when a test passes, the next thing is to write a test that doesn't pass. But before that, there is one step that they never mention in TDD. After you write a test that fails, and then write code that fixes it, it's time to push and stop, which is what I'm gonna do now. So I need to edit this. I have no idea how long that's gonna take. I probably have like close to 8 hours of recording. Most of it of me not doing anything, I imagine. So like, I don't know how I even edit that. Yeah, let me know what you think about this video.